look at another example on solving trig equations. This time I have sine of a double angle times cosine minus sine x equal to 0. Again, our goal is to solve for x, and the restriction is only between 0 and 360. So guys, looking at the left hand side, the first thing that I can see here is we cannot just directly take out any common factors, or we cannot just isolate a particular trig function. One of the things is that there's just by looking at this directly, we cannot, there's no common factors between them just by looking directly at this equation. And the other thing is like there's two different functions and there's a product of two different functions. So we cannot just simply isolate one of them right away directly from looking at the equation. Then if we cannot do any of those things, then one has to go back and look at the equation and see if there's anything else. Like, can we simplify the left hand side so that we may be able to isolate something or factor something? Guys, when I look at the sine of 2x, then we realize that sine of a double angle, we have a nice identity for sine of a double angle. And I'm going to remind you that sine of a double angle identity, I'm going to write it right here. We know sine of a double angle 2 theta is just 2 times sine theta times cosine theta. And you can find this identity, double angle identity, in your formula sheets. Okay. So if we substitute sine 2x by that, then we can see if that helps us to simplify things, or because otherwise we are kind of stuck, right? We cannot really do anything with this, this given equation. So we are going to substitute sine 2x equals to 2 sine x cosine x, and then let's see what happens. So it's 2 sine x and cosine x. I still have to multiply by the cosine x. So there's another cosine x times cosine x, and then minus sine x equal to 0. Now let us try to simplify this side. Guys, I can already see that cosine x times cosine x is cosine square, and then let me write that step first. I don't want to do everything in just one step. So cosine times cosine is cosine square x, and then minus sine x equal to 0. Now looking at this equation, again I can see that sine x and sine x occurs in both of these. So that means sine x is the greatest common factor, and I can take out that as a greatest common factor. So if I take that out as a greatest common factor, then what is left inside the parentheses? For the first term, I have 2 cosine square x, and here I will be only left with just a 1. Guys, from here I think this made our life easier now, because now we can see that I have a product of two quantities equal to 0, and using the zero product property we can set each one of them equal to 0. Let us go ahead and do that and then see if that helps us. Yeah, we can do sine x equal to 0, or this whole term inside the parentheses equals to 0. So we can clearly see that this is already a nice equation. Sine x is already isolated. So from here we can already start actually looking into the unit circle and finding the values for x that give me sine of x equal to 0. And the only value for that is, well, there are two values. There's 0 and 180 degrees. And we kind of, I mean, we just look at the unit circle for that, and we know it is going to be in the first or the second quadrant, because sine is supposed to be positive only in first and the second. So for this one, I get x equals to, so get two values for here. Looking into the unit circle, I get a 0 degrees, and then I also get 180 degrees. I just want to make sure that that's what I have here. Yes. And then guys, this guy, we got to do some extra work here. To isolate cosine x, guys, I have to add 1 to both sides, and then of course I have to divide by 2. So I get cosine square x will be 1/2 when I divide by 2 as well. Then I want cosine x by itself. To get cosine x, I just have to take the square root on both sides. When I take the square root on both sides, guys, what do I get? I get cosine x equals to, so I get two values, plus and minus. So it will be positive 1 over radical 2 and negative 1 over radical 2. Guys, we don't like to keep radicals in the denominator, so one has to rationalize the denominator by multiplying upstairs and downstairs by radical 2. Finally, when we simplify, I get radical 2 over 2. This is the one of the values for cosine. And then we do the same thing with this, rationalizing the denominator. We get a negative radical 2 over 2. Okay. Once we have these things simplified, now we have to go into the unit circle, and we have to identify the values for x, for which the cosine gives me positive and negative radical 2 over 2. Guys, positive means cosine is positive in the first and the fourth, and it is negative in the second and the third. So it is basically going to cover everything, all the four quadrants. So this one, I'm going to only look into the first and the fourth. So in the first and the fourth, what do I have? I have for radical 2 over 2, guys, this, I get x equals to, I'm looking at my unit circle, I get 45, I can see 45 degrees gives me radical 2 over 2. And then in the fourth quadrant, what do I have? I get x equals to 315. 315, yes, that is consistent with what I have in my notes. And guys, that takes care of the positive radical 2 over 2. Now for negative, we have to look into second quadrant and the third quadrant. So looking in the second quadrant, for this guy, I get x equals to negative is 135 degrees, and then there's one more, which is going to be 225. Let me make sure that's what I have. Yes, that's exactly what I have also in my notes. So these are the 4 values that satisfy this equation, and those 4 values are within the given restrictions, and these 2 as well. So there's like 6 of them. So guys, this is example 6. It has 6 solutions between 0 and 360, but we know like if we extend this to infinity, then we have infinitely many solutions. You just have to keep on adding 360k, or if you are thinking in terms of radians, it's 2 pi k, where we know k is any integer. It can be positive or negative. Guys, we already know and understand these sine and cosine functions. They are periodic functions. They keep on going for both the right and the left directions. Okay, so this is example 6. Guys, I will see you next time with example 7. Keep practicing these. If you have any questions, feel free to reach out to me. Till then, take care.